Okay, sorry about that. I had a little problem, so I have some writing on this already. But this paper is available on your D2L if you need it. In this video, we're going to go through some quadratic function applications so that we can see how we can use these in the real world. There's three types that I'm going to look at today: geometric, economical, and projectile motion. Projectile motion is where this is used most often, but it does help to maximize and minimize profits. So we're going to see all three examples. This first example, we have a rectangular vegetable garden. She wants to have a total area of 120 square feet. So I've written that the area is 120. And then we also know the formula for the area of a rectangle, which is length times width. Now the problem goes on to say that it should be 12 feet longer than it is wide, but they don't tell us anything about the width. So you can use W or you can use X, it doesn't matter, but I'm going to label one side width. Now I can associate the other side with this side by saying 12 feet longer is just W plus 12. Okay, so I'm going to plug this information, my length and my width, in my formula to give me that the area, which equals 120, is equal to the width W times W plus 12, which is the length. Okay, now distributing the W on this side here, that gives me 120 equals W squared plus 12W. And now we can see that it's a quadratic formula, quadratic equation. It's very easy to get it that in standard form here. If we move that 120 to the other side, that gives me W squared plus 12W minus 120 equals 0. And I can use the quadratic formula. Now, if you can factor it, but I already know that we can't factor it because I have tried so many factorizations. So I'm going to use the quadratic formula, negative 12 plus or minus the square root of 12 squared minus 4 times 1 times negative 120 all over 2 times 1. Okay, and then once you solve your quadratic equation here, you take the positive answer because we're in the real world. And I think, and you check me out here, but I think the answer is like 6.25 is the positive answer. You just plug that into your scientific calculator. You can use Desmos Scientific, and it'll give you the answer here. Just make sure that if this 12 was negative, then you'd put it in a parentheses before you squared it. Okay, so we know the width is 6.25. So now the only thing I have to do is add 12 to it. So we know width is 6.25 and 12 plus 16 is 18.25 for the length. And I made one tiny mistake here. I wrote this backwards, so I'm going to have to rewrite it because I left off my unit, 6.25 feet, and length is 18.25 feet. Okay, so set up the problem they give you by drawing a picture, use the formulas you know, rewrite it as a quadratic function, use the quadratic formula to solve it, and then get your two dimensions, because that's what they asked for. So looking at number 2 here, you have a 500-foot roll of fencing and a large field. You want to construct a rectangular playground area. What are the dimensions of the largest possible playground? What is the largest area? Interesting. Okay. Okay, so this is another case where they do not give us enough information. So we're going to just call this X because we don't know what it is. Now this side is equal to this side, so it's also X. And then how the heck can we figure out the top? Well, let's see. If I know that this is X and this is X, for perimeter, I would have to add them all up, right? 500 minus 2x would give us these two sides. Okay, so what if I said at most, you know what? What about this? Does that work? Hang on, let's see. Okay, so what I'm thinking is this side, I think that's right. So that gives us 250 minus x for this side, 250 minus x. And then this side is 250 minus x, because there's two of them. Okay, so what we can do, and I think your problem is not this hard on your page. I believe yours looks like this one. But if you're struggling, I think that's number, I don't remember anymore, 16 or something. But again, we would do the area is 250 minus x times x. Yeah, and then that would help us find the area. I'm going to pause on this one because this video is going to get too long with the other problems. But you do the same thing, distribute it, make a quadratic function, and then we can find the largest possible area. I'm going to go ahead and move on to economical problems here. Now, I'm calling these economical problems, but usually the question is asking you for the maximum or the minimum in this case. So this one is maximum in number 4 and the minimum in number 3. So what's happening is they give us this quadratic function. This one has a positive number out front, so I'm just going to draw you a little sketch real fast. This quadratic function looks like this with a minimum point. So what they're really looking for is the vertex. Okay, in this equation, we have a negative out front, so this quadratic function looks like this, and it has a maximum point, which is still the vertex. Now, in the last video, we found vertex, axis of symmetry, all of that stuff algebraically. That's exactly what we're doing here. And if you remember, I told you to memorize this formula. The formula to find the x, which is what we're looking for, right? If we're looking for backpacks here, we're looking for the x value to maximize the production level, is x equals negative b over 2a. So all the information we need is here, even though it doesn't look like they've given us enough information. Just be careful and make sure that it's the equation that you're working with starts with an x squared so that you know that a, b, and c are in order. So we're going to take off the b, which is right here, and we're going to change the sign because it says negative b. So x equals 210 divided by 2, and don't leave that 2 off, it'll change your answer, times 0.5. Okay? Okay, so 2 times 0.05 is 1, so 210 divided by 1 is 210. Now, this number represents a unit of something. They told us that x is backpack, so this is 210 backpacks. Don't forget your units. But that's not all they asked for. They asked for the production level to minimize it. That's the number of your x. That's your backpacks. And then find the weekly minimum cost. And if you look in the equation, it says the total cost is given by the equation c of x. So we can plug in x into the equation and find out the cost of 210. So the cost of 210 backpacks is 0.5 times 210 squared minus 210 times 210 plus 26,250. Okay, so I'm going to plug that in my calculator just like it is, straight down the middle, and let's see what we get. Notice that I used a positive number. If in these problems we get a negative number of backpacks, on your homework, if you get a negative number of chandeliers, you've lost your negative somewhere, and it was probably in this x part, right? So be careful. We're using positive numbers, positive money, right? So I got 4,200. 4,200, and that is in dollars. So those are my two answers, 210 backpacks and $4,200. Okay. I'm just going to do this one again just to make sure we're using the right equation. X equals negative b over 2a. So making sure they're in order, x squared, x, and then a constant. So yes, this is b, negative 3.4 divided by 2 times negative 0.02. Okay. When I'm working this out, because I have a little dinky calculator, I'm doing the denominator first, 2 times negative 0.02, just so I don't have to use parentheses. Darn it. I got 85 DVDs. Now, if I'm looking for maximum profit, I'm going to plug that back in. Notice I didn't even read the equation. I don't even know we were talking about DVDs except for I looked at the question. So for these, you really need the equation they give you, and then you're finding x, and then you're probably plugging that in to find your p of x. So I'm not going to work this one out. I'm just going to plug it in for you so you can see where the 85 goes. Okay, and then we get an answer in dollars, and that would be your maximum profit. Okay, you have a couple of those to do on your homework, and I believe I put those questions on the test, so make sure you know how to do those. I'm going to show you just one of these projectile motion problems, because the video is getting kind of long, and there's a lot to do this week. So the following equation represents the path of a donut hole being thrown by the hatter, where x represents the time in seconds, and the donut is in the air, and y represents the height in feet that the donut falls. So to put this in perspective for you, I'm going to draw you a picture of what's happening. Anytime anything gets thrown, a football, a basketball, a donut, or anytime anything is launched, it always goes up and then comes back down. You probably heard that saying before. It always makes some sort of parabola, right? So anytime they're asking for a maximum height or a maximum time, this is still a vertex question. What's important is that you know which one is which. So here they're telling us that x represents the time in seconds. So the x-axis is the seconds that pass. This is usually time. And the y represents the height in feet. So it kind of looks like what is happening. So if I'm asking for maximum height and maximum time, that's the vertex. If I'm asking for how much time Alice has to catch the donut before it hits the ground, anytime it's saying something about the ground, that's an x-intercept. So these are three different types of problems here. Okay, if we're looking for maximum height, that's still the same equation. Even though we're in a different type of problem, we're still doing x equals negative b over 2a. So x equals, the opposite of a positive 4 is negative 4 over 2 times negative 1. I'm sorry that I wrote over that. I'm a crazy person. So this is positive 2. So the maximum height of the donut is 2 seconds. Look at that. I answered the wrong question in the wrong spot. At what time does it reach the maximum height? So that goes here. And I didn't notice that until I checked my units. So x should have been time, so I went ahead and wrote seconds after it. So now I need to answer the original question of the maximum height. To do that, I plug in that 2 seconds into my equation. Negative 2 squared plus 4 times 2 minus 2. Notice that I didn't put the negative in my parentheses because the x on the outside is negative, not the 2 that I found. So that is -4 plus 8 minus 2, which equals 2 feet. Okay, so I answered them both. I just answered them in the wrong place. Now if I want to know how much time Alice has to catch it before it hits the ground, that's where we have to solve or factor. But it looks like I can't factor because 2 times 1 is prime, and I will never get a 4 here. So I'm going to use the quadratic formula. X equals negative, goodness, today is a struggle. Okay, so x equals negative b plus or minus a square root of b squared minus 4 times a times c all over 2 times a. Okay, so we're going to do some magic here. I'm going to plug that in. Okay, again, when you use these problems, we're looking for the positive answer. Doesn't make any sense. I figured out why it didn't make sense. I had to do the other side. So I got 0.586 seconds, which I know is not right because that's before I reached the maximum height. So I tried the other one, -4 minus the square root of 8 over -2, and I got 3.4 seconds. So that makes more sense to me since it's on the right side of the vertex here. So 3.4 seconds. And it's really close to 4 seconds, which is what it would be if it was even on both sides. The only reason it's not even on both sides is because this side, we don't know what height the Mad Hatter threw it from, right? It looks like probably 2. But anyways, that's how you do those problems. If you need help, please send me an email, ask for help, or reach out to the tutor.